My presentation is interactive virtual outcrops as teaching tools, two examples of outcrop structures associated with the trusts. My name is Riccardo Rocca, and these are the topics that I will follow during my presentation. An introduction and the scope of my activity, the workflow and software that I use, an introduction to the geological area that I will be presenting, and two examples of virtual outcrops associated with fault trusts, and finally a few conclusions. About myself, I'm a geologist. I've been working as an exploration geologist in the oil industry in the latest year with Repsol here in Madrid. And for my personal interest, I started flying a drone and capture images of geological outcrops, and then generate 3D models. And then I learned how to add more elements to this representation, like in this case, the surface representing the anticline of this structure. And I did this exactly for this activity with this association, AGEP, which is a Spanish association of geologists and geophysicists. And what we did in June 2019 was to make the experience of flying a drone and capture images and generate the 3D model of the outcrop. And from these activities, I started to develop ideas on how to make these virtual outcrops useful tools for this kind of educational activities. So, in order to show what I mean by the usefulness of the virtual outcrops in this case, I want to show these examples of a field guide edited by the professors Vicente and Munoz Martin regarding this stop in the province of Guadalajara in the northeast of Madrid. And this stop is presented with a classical representation, with a picture of the area and with a graphic cross-section. And from the indication, we understand that a certain thrust on the section is the fault that we see present in the outcrop. Now, I would like to compare this with this kind of representation with this other kind, where we have the outcrop represented as a 3D model and completed with a representation of the surfaces that represent the geological structure that is present in this outcrop. And so I make a list of the various steps that I use to generate that kind of output. So I start with flying a drone and acquire images. Then I process the images with the photogrammetry software. Then I include additional information, graphic information in the form of geological maps and sections, and I georeference them with a GIS software. Then I join all these elements with a 3D editing software. And finally, I publish the resulting model with a 3D publishing platform that allows me to share the model with a very large number of users through the internet. And so let's come to the examples. They are located in this area, right in the center of the Iberian Peninsula. It's an area where we have the interaction of two mountain ranges, the Central System and the Iberian Chain. And they generate a very special landscape made of numerous small-scale geological structures that are ideal to be captured and represented as virtual outcrops. Here is the city of Sigüenza, for those who know it, and we focus on two fault thrusts, the Wermeses and the Baides thrusts. And we have a section crossing them, so this is the section. And these two thrusts have different features in the surface. So the Wermeses thrust actually reaches the surface and deforms the strata, showing at the surface a pack of vertical strata. The Baides thrust, on the other hand, does not reach the surface, but it deforms gently the surface in the form of anticlines. So let's see a first example, the Wermeses thrust. And this is the general map, but now we reorient it and we show it together with the cross section. We focus in on the Wermeses thrust, on the outcrop that is along the fault trace over there, and we zoom in. And this is the outcrop that I've shown so far. So we remove the other elements. And this outcrop, as I was saying, is very characteristic for this pack of vertical strata. They are Eocene carbonates, and we highlight them with this graphic trick. On the other side, there are also carbonates, but they are of a different age. They are Cretaceous. And so we have one side with Cretaceous carbonate, the other side with Eocene carbonates. In the middle, there must be some kind of discontinuity. Regarding on the stratification on this side, it is more easy to get an idea if we expand the model using a satellite image. The resolution, as we can see, is not comparable with the part captured with the drone, but nevertheless, it helps us to have a full picture of this feature of the landscape, and especially to identify the stratification. And so more in detail, we highlight a couple of strata, like this. And based on this, we can model the surface that represent these Cretaceous limestones. Here it is, and on the other side, we represent also the surface associated with the Eocene carbonates that are vertical at the surface, but in the subsurface they flatten out. And they become vertical because they are dragged and deformed by the fault thrust. And here is the fault. So if we now switch off all the additional elements, now we remain with the initial outcrop, but this time completed with all these graphic elements that help us understand what is the full geological structure represented by the outcrop. Now, I would like to briefly review some of the elements that are characteristic of this model. So, as you have seen, I have added images and topography from satellite data. I have added maps, geological maps and cross sections. Interpretation in the forms of the strata and the surfaces. And then I have added these buttons at the corner that allow to switch on and off the single elements of the model with the help of some JavaScript code. And finally, I published this on the internet, so it becomes a very portable object that can be displayed on a tablet, for instance, like this. And provided there is internet connection, it can be brought to the field and be used during a field trip, for instance. So now let's review all these elements with a second example. We start with the general map again, and we switch to the cross section, but this time we focus on the bias thrust. And we have an outcrop right at the tip of this fault trace. And this is the outcrop. As you see, it's a gentle hill with this special form, curved, the shape of a crescent. And we have strata along this hill. They're even more evident with this grayscale texture. And we highlight the longest one. And if we model the surface consistent with this strata, we see that it is an anticline with the axis that is dipping. Now, regarding this crescent shape, it is something very recurrent in this area, and we can see it if we zoom out and if we add the satellite image. So we see that in the alternation of hills and fields, we can recognize over and over this crescent shape. And we can highlight it even better using colors like this. And now if we add the geological map, we see that the geological map also has this shape represented, together with the axis of the fold that dies out and dips towards the opposite end. This geological map comes with a section, and if we include it in the model, we can see the interpretation in the subsurface, where we have actually a thrust that displaces the horizons down to a certain depth, but at the surface then it only propagates mild deformation. And now if we extrude this interpretation with a couple of surfaces in order to give a third dimension, we see that the shallower layer has this shape of an anticline with the axis dipping, consistent with the interpretation that we did in the beginning with our outcrop. And so now we see the outcrop again, but this time included in a complete geological interpretation that gives us a much better idea of the geological structure associated with this outcrop. And so we reach the conclusion. Here are a few ideas. So what I wanted to show is that virtual outcrops can be greatly improved with editing by integrating geological maps and sections, interpretation, animation, etc. And they can become a valuable educational tool in support of geological field trips, but also, for instance, scientific papers. And this is my last slide. I put here the references to the software that I have used, the reference to the field guide that I have mentioned, my contact, and the links to the models that I have shown and to other models that I have created. Thank you.